In this example, we're asked to divide one rational expression by another. And again, we're going to borrow from ideas from when we did manipulations with fractions. Here, let's take a look first at multiplying fractions. Now remember, when we had two fractions that we multiplied together, for instance, say we had 24 over 35 times 45 over 36. Okay, how do we do that? Well, we could do numerator times numerator, and then denominator times denominator. Okay, multiply them out, simplify, and we're done. But remember, when we multiply fractions, it's sometimes a lot easier, instead of doing this multiplication, get big number, get another big number, and then finding what they have in common. It's a lot easier to cancel those things in the first place, get some common factors going in the first place. So here's what I'm going to do with this one. That numerator, I'm going to rewrite as 2 times 12, that's the 24. And then, let's see, 45 is 9 times 5. I can go 5, and instead of 9, I'm going to write times 3 times 3. Now, I haven't fully prime factored these things, but it's going to turn out to be okay, because I'm sort of looking ahead on you here. Okay, in the denominator, 35, well, 5 times 7 is the only way I'm going to factor that guy out. And then the 36, I'm going to go 3 times 12. Okay, so now I've got a bunch of factors in the numerator, a bunch of factors in the denominator. And remember, that means that I can cancel all over the place wherever I see a common thing in the numerator and denominator. So I'm going to start with the big one. I can get rid of this 12, for instance. Anything else in common? Yeah, I got a 5 here, I got a 5 here. I got a 3, and one of the 3's up top can cancel. Let's see, is there anything else? Nope. So what am I left with? I'm left with 2 times 3 over 7. Which is just 6 over 7. Now that's much easier than what we had originally thought about, maybe multiplying two pretty big numbers together and then simplifying at the end. So remember, when we're multiplying fractions, you try to factor things out, cancel them, simplify, and then do the multiplication. All right, next thing, dividing two fractions. How do we divide two fractions? So dividing fractions, let's say we have 5/12 divided by 15 over 24. Well, it turns out the way we divide fractions is to multiply by the reciprocal. Let me write that right up top. Multiply by the reciprocal. All right, let's see what that means. 5/12, and now I'm going to multiply instead of divide. And the reciprocal simply takes the fraction, 15 over 24, and flips it over. So instead of 15 over 24, I'm going to write it as 24 over 15. Okay, so basically when we divide fractions, we turn the division into a multiplication of fractions and proceed as usual. Now I'm going to do the shorthand method of cancellation here. So for instance, 12 goes into 12 once, goes into 24 twice. The 5 goes in once, and the 5 goes in 3 times over here. And I think I pretty much simplified everything, so do my multiplication and get 2/3. So the result of 5/12 divided by 15 over 24 ends up being 2/3. And I tell you, dividing fractions is almost as easy as multiplying the fractions. Just remember that you have to multiply by the reciprocal. Okay, let's get back to our original problem here now. So in this one, we've got two rational expressions, and they're divided by each other. So first step is we've got division of two fractions, right? So let's change that right off into a multiplication of two fractions. And we multiply by the reciprocal, which means we just flip the fraction over. Okay, the next thing that we did, when we had two fractions that we multiplied together, remember we factored them out. All right, so let's see, the factorization of stuff. Let's see how we can work this thing now. Well, it turns out that I'm not going to do the heavy work here for you already. 3x squared minus 10x plus 8 does factor out to x plus 2 times 3x minus 4. Okay, so that's the first one. That's the hard one that we got done. The other one, 21 here, well, that factors out to just 3 by 7. And then let's see, the denominators, they all factor out. Let's see, I'm going to pull a 7 out front here, and I'm going to be left with an x minus 2. And then this 9x minus 12, well, the only thing in common there looks like is a 3. So I'm going to pull a 3 out of there and end up with a 3x minus 4. Okay, so I've fully factored the numerators, the denominators, I've multiplied numerators times numerator, denominator times denominator. Now I have to see if I can cancel anything. Let's see, let's start with the x minus 2. Yep, I got x minus 2. I got a 3x minus 4. I got a 3 and a 3, and look at that, I got a 7 and a 7. And everything in sight cancels. When everything cancels like that, only 1 is left over. So I'm really left with 1 over 1 here. And the final answer to this particular division problem is 1. So what did we do? If we're dividing two rational expressions, just like fractions, you multiply by the reciprocal of the second one. We then factored each one of the numerators and denominators, multiplied the numerator times numerator, denominator by denominator, cancel out the common factors in the numerators and denominators. Remember, factors are things that are multiplied together. Cancel them out, and whatever's left over, we do the multiplication. In this example, what was left over was just 1, so pretty easy final result for us.